I want to take a look at three, I call them special examples just because they're a little different in how we have to handle them. So the first one says, write the equation of a line. The slope is undefined and it contains the 0.51. So this really doesn't fit into a case 1, 2, or 3 scenario because of that word undefined slope. So I like for you to think of it from a graphical standpoint. You know it has to go through the 0.51. An undefined slope would mean a vertical line. So they want the equation of this line right here. So anytime you have a vertical line, we're going to use the letter x. In this case, x equals 5. If you're not sure why you have to use x, it's because all your y values on this line are ever changing, but your x values are always going to be 5. Like this is 5, 4, 5, 3, 5, 2, 5, 1, 5, 0, 5, -1, etc. So as long as all your x values are 5, your y values can be whatever, you'll still be on that line. All right, then they might do one of these. I see this all the time. So they'll give you 2 points, and a lot of kids will think, this is a case 3. So I want to point out what's going on here because this is, again, I see this all the time. So I'm going to set up my slope formula, and I'm going to do y2 minus y1 over x2 minus x1. And what you get is -1 over 0. Here's where kids go wrong. They'll go ahead and write equals 0, and then they'll continue on with their steps. As soon as you do that, you're wrong. You can't have this. This is undefined. You can't divide by 0, so that means you have to stop working. There's nothing you can do in terms of algebra here. So you just have to know what's really going on. So imagine if you plotted the points 4, 3, and 4, 2. When you connect them, your line is vertical. Hence, you didn't get an actual slope. It was undefined because there is no slope of a vertical line. So we just write our answer. We just have to know this means x equals 4. Okay. So watch out for that. If you ever get 0 in your denominator, you have to stop working and you have to realize this is going to make a vertical line. Right, and then number 3. So it says write the equation of a line. The x-intercept is 4. The y-intercept is -3. So yeah, if you have a graph in front of you, you could quickly plot them and you could see, oh, okay, here's the slope. That's what, 3/4, and the y-intercept's -3. I can set it up. I want you to be able to do it mathematically though, because I might change the 4 to like 41.2. And I might change y-intercept to -3.8. It's not going to be as easy just to simply count your slope. So I want to point out a couple things to you. Anytime I give you an intercept, I am giving you an ordered pair. The x-intercept is 4, 0, and the y-intercept is 0, -3. So you really have a case 3 going on here. The good news is, I already told you the y-intercept is -3. What you don't have is the slope. If you had the slope, you would go ahead and use slope-intercept form. So that's your task. You need to get slope using these 2 ordered pairs. So you go ahead and set up your y2 minus y1 over x2 minus x1. You will get -3 over -4, and that becomes +3 over +4. So your slope is 3/4, of course. And then once you have that, you can plug in your slope and your b value. Now you have your equation. We'll run through this really quick. Again, you're supposed to learn this in Algebra 1. Let's just make sure you remember. So if you're writing the equation given a picture, you're going to set up your slope-intercept form first. So set up y equals mx plus b for numbers 1 and 2. You need to fill in the slope, and you need to fill in your y-intercept. So in this case, to get from one point to the other, I have to go down 2 and write 3, or up 2 and left 3. Either way, your slope is -2/3, and your y-intercept is 2. Number 2, you have to go up 3 and over 1. So that's your slope, 3 over 1. And your y-intercept is 3. So 3x plus 3 is going to be the answer for that. Number 3, again, that's one of those special lines. We saw that on the previous slide. So we know that the equation of any vertical line is x equals the x-intercept, which is 4. And that's going to be opposite for a horizontal line. So we know that this is technically a constant function, but the equation of it is y equals the y-intercept, which is 1. And then number 5, this is actually your parent linear function, something you've already been writing the equation of, and I've been having you guys write f of x equals x, so I just wrote y equals x, so it looked more like your Algebra 1 days. All right, but the slope is 1 over 1. The y-intercept is 0, so obviously you don't have to write 1 in front of x. You don't have to write plus 0, so we just write it like that. And number 6 is just opposite. It has almost the same slope. It's just going downhill, so we just make it negative. And there's your equations from your lines. So in my next video, we'll go ahead and do what I think is the trickiest for my students in Algebra 2. I think that's trickier for them to convert between forms. So that's what we're going to cover next time.